Hi everyone. Today I'm going to run the simulation and comment on what's happening on the screen. Let's go. We are starting the project. At first try, it won't launch from time to time. Yet sometimes we can get a rather successful tree. There is little variation so far. And so, here we have such a tree. The genome is visible on the right side of the screen. On the top left side, we can see the number of tree cells, the amount of energy, and all this was accumulated in 90 moves. This is a generation number. A generation here is considered every 90 steps. Initially, the color of the tree is set randomly. All descendants of this tree will have the same color. Only mutants that had a change in their genome will have a different random color. Here we have a new species with many offshoots on the right side. There is no big sense in this, since most of the offshoots, turning into seeds and falling to the ground, will die. Now there are only two species in the world. They differ only in one significant gene. The species with a large number of offshoots could not gain a foothold and, leaving no offsprings, disappeared. And here is a new species. The clusters of offshoots are on the left side already. The seeds fall to the ground tightly. They want to grow to the left, but there are already other seeds. Therefore, only the extreme left seed ascends. A new species with a crest appeared, but it immediately disappeared, as it threw the seeds unsuccessfully. This is what the dominant species looks like now. A sort of creeping species appeared and quickly disappeared, deprived of the sun. Sometimes life almost disappears. The population is minimal. The world is still clearly small and needs to be expanded. Here is a new species looking like a comb. This is what it and its subspecies look like. That's an amazing variety for such a small field. Here we already see many species growing at different angles. A plant looking like a flag appeared. The flag quickly disappeared, and the field now features the following species. Time is running. The tree shape is slowly changing, but these are all subspecies of the first V-shaped tree. Here is another tree that looks like a flag. After the death of the tree, all offshoots, turning into seeds, receive 300 units of energy. This is not an ideal solution. All energy accumulated by the tree has to be distributed among all seeds of this tree. So, the following directions of development exist. Either many seeds with a small amount of energy, either few seeds with a lot of energy, allowing them to survive in the shade for some time. It will be seen as advantage to have thinner, graceful forms to bring more energy to the seeds. Even now, however, there is a similar trend. Currently, the trees have a massive crown, but on the later stages of evolution, the branches in the crown usually become one cell thick. All the energy collected by ordinary cells goes into a common pot, then distributed to feed the entire tree. The offshoots accumulate all the energy and use it to create new cells. While the offshoot is falling to the ground, it can also collect energy. Here's a new trend. The offshoots of the right branch are only in the lower part of the tree. Here are a couple of such trees. The lifespan of a tree is set randomly at the very beginning within a range of 88 to 92. Since the lifespan of all trees is slightly different, over time, the life cycles should disperse. However, they are clearly synchronized. Disappearing later than others brings no benefits. The seeds will fall on growing trees and won't reach the earth. If you disappear much earlier than others, the seeds will be left in the shade of other trees. The first trees with a crown appeared, as well as plants using something like a tail. This tree on the right with its so-called tail simply blocks the light for all its neighbors and prevents them from approaching. The tree with an extensive crown disappeared, and the tailed species is slowly starting to crowd out all the others. And next, one tailed tree started having something like a crown. A beauty resembling a fern appeared. I want to add a couple of commands with the gene. The first command is to reduce the lifetime by one move. Perhaps some species would benefit from a shorter life cycle. On that, energy won't be spent. The second command is to increase the lifespan by one move. The tree energy will be spent on this, and for each new additional move, more energy will be taken. Let's see where all this leads to. Once again, a tree with a crown appeared. A tree garland. This is how it looks. Some trees, in case the light is blocked, start sprouting many offshoots. Here are the types we currently have: with a tail, no tail, only a tail, and a minimalist one with two offshoots. I'm not showing all the types possible. When modeling, a huge number of different species, subspecies, and varieties appeared. Many of them differed literally by a couple of cells. And now we have a new species with an elegant tree crown growing to the left. Little time will pass, and this species will dominate. Pay attention to how effectively the crown clears the ground under the tree. Nothing grows under the crown because the light does not reach this area, and the seeds of this tree fall on a free land. Here comes the new upright species. This is the previous subspecies, and this is the new one. Yet it turned out to be short-lived, and quickly enough it was forced out. Sometimes atavisms appear, and trees grow without a crown. And then trees began to appear where the crown is on both sides of the trunk. Here's a funny species I came across. Its energy was gone. It can't survive on its own. I spotted it at an early stage and artificially brought it 90 steps forward to see what it looks like. Meanwhile, trees with a crown in one direction aren't willing to give up. They changed places several times. Sometimes trees with a crown in two directions were dominating, and sometimes trees with a crown in one direction were dominating. As a result, trees with a crown in one direction remain. Actually, it is almost ideal for this world. For a long time, no one could remove it. It is very similar to one species that quickly disappeared a long time ago. But they aren't related. They have a very different genome. Further, for a long time, nothing was changing in the world. So I turned the simulation off. A little less than 5,000 generations have passed. While editing the video, I tried to make changes to the code. As I planned, now all the energy of the tree, when it reaches its maximum age, is distributed among all the seeds of this tree. I also added the following aspect. Seeds no longer die when they fall on anything other than the ground. Seeds are now displayed as yellow dots. Here, 4 endings of the 4 simulations are presented. Since it's now important to have more energy, the trees have become straighter. They grow up and have thin branches. To get the maximum energy, the tree should be taller, as wide as possible horizontally, and it should try to get by with as few cells as possible. While I was editing the add-on to the video, I made one more change to the code. Now the record of the tree lifespan begins from the moment the seed touches the ground. Now the seed, being on the sun and not touching the earth, can exist infinitely. On the screen, you can see the way evolution developed following these rules. The ground was covered with a layer of seeds. It only complicates the evolution, since it isn't clear which properties a tree must have for its seeds to reach the ground, also having free space above for their growth. Although slowly, the evolution is still happening. And you can also make the unsprouted seed turn into the ground over time. When growing, a tree pumps substance out of the ground, turning it into material for creating cells. Then it all rots and turns back into the ground. One of the components of the atmosphere can also be used for this. The atmosphere will change, stimulating new species to emerge. In the world, one substance is transformed into another through life, using the energy coming from outside. Here are just my thoughts so far. That's it for today. Bye, everyone.